So in addition to adding on alcohols, we can also add on amines as well. So amines are similar to alcohols, but they use the nitrogen atom instead of oxygen. So if we start with a amine and add it to our carbonyl instead of an alcohol, we get a very similar hemi-aminal intermediate. So that's similar to our hemi-acetal or hemi-ketal. The only difference is that instead of producing our acetal or ketal, we actually eliminate water and we end up forming a nitrogen-carbon double bond. So this happens with a primary amine, which is an amine that has only one bond to carbon. So there's two hydrogens and one bond to carbon. With a secondary amine, we end up forming an enamine, where we have a carbon-carbon double bond next to our nitrogen. So a secondary amine here has two carbons attached to that nitrogen. We again get our hemi-aminal intermediate, where we add on that nitrogen similar to how we would add on an alcohol. But again, we're eliminating water to get to our final product. So with all of our carbonyl addition reactions, so start out with our carbonyl, and we're going to react and add on our component, and then we can either, in the case of amines, we're going to eliminate the oxygen actually, so we eliminate water in our second step. With alcohols, of course, we add on our two alcohols to get our acetal or ketal. So in every case, we're going to start with the addition. So we take our amine. So an amine is going to have a nitrogen group with some hydrogens attached and maybe some carbons also. So our nitrogen can act as a nucleophile, and we're going to attack that carbonyl carbon. So this is our electrophile with partial positive charge. We've got our nucleophile with partial negative charge. We attack, and then we're always using that second arrow there to move our electrons out of the way to make room for the new bond. So you get this tetrahedral intermediate where you have the nitrogen bonded, and then you also still have that, you have the oxygen sp3 hybridized with a single bond to the carbon instead of the double bond. So now we have a series of proton transfers that will occur here. So we can transfer we can protonate our oxygen, and then we'll want to deprotonate our amine. So we're going to restore it to a neutral state. So we don't have all of our charges. So our amine reacts as an acid, and our oxygen reacts as a base. And then this would be basically this is the equivalent of a hemiacetal, a hemiaminal. Right, so we added on our new amine group, but we still have our original carbonyl oxygen as an alcohol there, just like we would in a hemiacetal. Right, so if we reacted this with an alcohol instead, so that would be, we used ethanol, a similar alcohol, we would have ended up producing this as our hemiacetal product. So you can see the first steps really are very similar to what we would get with an alcohol addition reaction. So now that we formed that hemiaminal, it's the next steps that give us our unique product here. So instead of adding on another unit of alcohol, right, so with the hemiacetal, we would react again with another unit of alcohol, and we would get our full acetal. With the hemiaminal, we're going to eliminate this guy up here, and then create our imine. So the first thing we have to do, of course, whenever we're eliminating an alcohol group, is we need to protonate it. So we're going to use acidic conditions, and we protonate that alcohol group. Now we've created a good leaving group up here with our oxygen that's positively charged. So that's our water-based leaving group. So now we can eliminate our water. So we can pull that off. And then we can also bring down our electrons here from the nitrogen and form a new double bond. Now our nitrogen is positively charged, so to get our final product, we can just remove that hydrogen there in an acid-base reaction. And so our final product is a imine. So alcohols we add together to our carbonyl to eventually produce acetals or ketals. Nitrogens will produce amines, or they can also produce the enamines if we have a secondary amine. So this right here that we used is a primary amine. So what primary versus secondary, tertiary is defined for amines based on how many bonds they have to carbons. Right, so this has one bond to a carbon. This would be a secondary amine. It has two bonds to carbons. And you can have a tertiary amine. Would look like this with